Great. Thanks so much, Eliza, and welcome everyone. Very excited to host at Ballina today. And I'll give a little bit of an intro about myself and just kind of plug in Augury just for a minute or so. And then we'll kind of take it from there. So I serve as VP product at Augury, where I oversee the products that we create. And really, it's an exciting role to be in because I believe we're solving some really big problems in this space. And what we do for those of you who are not familiar is we combine industrial IoT with artificial intelligence to accurately identify machine malfunctions and also predict machine malfunctions. And so that is the kind of problem that we address at Augury. You can always check us out at augury.com and follow up with us. So I'm pleased to introduce Ed Ballina. And hopefully this is one of many speaker series that we're going to host through these webinars. Ed Ballina has over 36 years of experience in manufacturing and reliability. He's worked across 3 Fortune 50 CPG companies. He was formerly VP Manufacturing Warehousing at Pepsi, but he has also worked in beverage and paper industries. And he has led teams focused on improving equipment RE and TE performance and reducing maintenance costs while improving field capabilities. He also served as Senior Director of Supply Chain, CNO, Senior Director of Manufacturing Warehousing for both Southeast and Northeast regions, with responsibility for all bottling plants, including CSD and Gatorade in PepsiCo geographies. He began his career in 1982 at Procter & Gamble, where he held a number of roles in engineering, maintenance, and production management. He then transitioned to Scott Paper Company, where he continued his career progression leading larger manufacturing organizations in their Pennsylvania location. In 1995, he began his career with PepsiCo, where he held a number of different roles, leading line improvement initiatives, and he was a plant director for several bottling facilities, including Pepsi's largest plant in Denver, Colorado. And this is all before he, of course, became VP Manufacturing Warehousing. So, Ed, really excited to have you here with us. Thanks for joining us.
Thanks, Artem. It makes me feel tired after listening to all that stuff over the years. But it's been a terrific run with a number of really fine companies, and enjoying my semi-retired state now, engaging with a couple of different companies on an advisory from an advisory standpoint. So thanks for the intro.
Absolutely. So I'll just kick it off with this conversation, and I think my first question is, you've served in a lot of different roles. And within these roles, you really were in charge of reliability and engineering and in large companies. And you must have a pretty good perspective on the evolution of different technologies that you've seen over the years. And let's just kick it off by saying, what have you seen change in recent years?
Well, as you mentioned in my intro, it has been exciting to kind of witness some of the industrial revolutions over my career. Most of my roles, as you mentioned, were in the operating field assignments, whether it was leading production organizations, leading plants, and then eventually groups of plants across different regions. I only held really 2 staff assignments in my whole career. I don't know whether that's good or bad, but I enjoy the action in the field. And both of those were focused on driving reliability. They had different names and different scopes, but in general, it was trying to figure out how to get more uptime out of the assets we currently had. And we all know the progression of manufacturing, starting with the early industrial revolution, with the steam engine, moving on to the assembly line, then automation and robotics, kind of the birth of computers in manufacturing. And now we're in the cusp of what we're calling Industrial Revolution 4.0, or call it IIoT, but digital manufacturing is another term that's used. But really exciting to be in this stage right now of development where we're seeing the promise of digital capability really starting to take root in manufacturing organizations across North America. Now, the promise is still there. It is out in the horizon, I would say, but we're starting to see some tangible applications out there, albeit at somewhat nascent stages. Whether it's diagnosing sensors that will actually tell you what's wrong with them, lot traceability, which is a huge issue as it comes to food safety, and especially with the Food Safety Modernization Act enacted by the federal government in the U.S., which really pushes manufacturers to be able to tell you exactly all the source components that went into a finished product and trace that through the supply chain. Whether it's utility sustainability and tracking is another big early use of this technology. But frankly, for me, the most exciting one is the whole predictive maintenance framework, because that's an area where the technology isn't nascent; it's there. The perspective or opportunity to use vibration analysis to determine equipment failure has been around for a long time. As you and I have talked, at least my engagement with it started, probably 20 years ago, and it came out of the submarine business, if you want to call it that. Loud subs are dead subs, and subs that don't run are dead subs as well. So my experience with it came from folks who had been in the U.S. Navy submarine program, that when they came out into industry, they brought those skills with them. So the use of vibration analysis has been around for quite some time, but it's taken some time to get industry to adopt it, to believe in it, and to start using it. And to me, that is kind of the first stage of embracing this digital manufacturing opportunity. So, and the other thing that's causing us to do is to change our thinking as it relates to how we think about manufacturing lines. Historically, we thought about lines as collections of machine centers. So I have a palletizer, I have a packer, I have a filler, I have a paper machine. They're connected, discrete unit operations. When in reality, they work in concert with each other. Think of it as an orchestra. You don't just listen to the violin. You listen to the violin and the trombone and the piano, etc., and they are synergistic. The same thing with a line. And this IIoT is really starting to push us to think about lines as ecosystems, because you can have the fastest palletizer in the world, but if it can't be fed with product at its rated speed, then that extra capacity is underutilized or wasted. And you can say the same thing for even the smallest conveyor on the line. It becomes a restricting orifice. So thinking about lines as ecosystems rather than just unit ops or machine centers is part of this Industrial Revolution 4.0. So it's exciting. It's exciting to see this starting to take hold. And I believe all the promise of IoT will come to fruition. It's just going to take some time.
Yeah, that's actually very interesting. There are so many different applications that you've mentioned. Of course, predictive maintenance and a number of others as the promise, but it also seems tangible in many ways. So that promise of bigger, faster, deeper into data insights and stronger, and can have a wider view at the same time, a better understanding of the details of the process. But the adoption, at least in our experience, hasn't been as fast as I would say that the promise, right? The promise would
right.
Both. So what do you think were or have been the barriers to adoption of industrial IoT so far, and where have you seen these barriers eliminated?
So as you and I have talked in the past about manufacturing and how most of us that have been around that world approach it, manufacturing is all about controlling the process. And I've joked around about this concept called entropy, which is a force in the universe that drives things towards chaos. That entropy is our biggest enemy when you have a manufacturing enterprise. You've got things that are varying within their normal variability. You've got equipment at different states of wear. You've got operators inputting different settings. So as a result of that, manufacturing folks tend to be even more than normally resistant to change and afraid of new things. Because frankly, those of us that have been around for a while have had experience at some point in time with emerging technology, right? So equipment number 001. And usually those experiments don't go very well for the early adopter. I shared a story with a friend the other day about an early adoption of technology in the paper industry. When I worked for Scott Paper Company in Chester, Pennsylvania, they invested hundreds of millions of dollars in a cutting edge coal calm burning machinery equipment. It was massive. Coal calm is the byproduct of coal mining, and this is Pennsylvania, right? Coal mining has been huge, or had been huge here for nearly a century. But you had these mountains of coal calm that were around all the coal mines that were free for the taking. In fact, municipalities would pay you to take it. Paper making is a very energy intensive process. So Scott Paper was rather forward thinking at the time and thought, you know what? Wow, this is great. Sustainability was not a big buzzword back then, but it was good for the environment. It was a free source of fuel, maybe even less than free. They would pay you to take it. Wow, what an opportunity to significantly cut almost a quarter of the cost of making paper by getting this free energy. So they invested in this, it was called a Chester Cogeneration Facility, CCF. Great idea. I probably still bear the scars of that on my back from being in operations there, because it was very unreliable. And there were all kinds of issues with the technology. I applauded them for being forward thinking, but at the end of the day, I would say if they were to rethink that decision, they probably would not have gone down that path, because it wound up costing more money. So, and lots of instability. So just a little example, manufacturing folks don't like change. So here, we're talking about not just a little change, but the next industrial revolution, right? Sensors telling us how they're behaving, algorithms being developed to try and understand, what's the optimum point for these processes. And you've got folks saying, you know what, let somebody else try that, because, let them work out the bugs. So that's the biggest impediment to change, to implementation is that, but there's a number of others. First, we are really starting to become very aware of the issue with data breaches, right? Most large companies have whole IT, small villages now focused on how do we keep our data safe? How do we have the right firewalls? And now we're coming across saying, hey, we're going to have all these machines talk to each other, and then they're going to send data to the cloud. And boy, that keeps a CIO awake at nights. So that's one concern. And also, once you kind of just get your foot in the door with this IoT, you start realizing the massive amounts of data that this system is going to generate. And let's face it, in many facilities, I joked around that in my home, my internet speed was probably 10 times what was available on the shop floor where I worked. So the systems of the plants are mostly lagging behind in terms of their bandwidth, the speeds, and now we're talking about, just amounts of data that are almost incomprehensible. So that's certainly a concern. Then the whole fear of, I don't know what this IoT is. I know how to spell it, but what does it really mean? And it's a bit of a fear of the unknown, which is kind of coupled with this whole fear of change. At the end of the day, to me, the two easiest ways to try and broach this is, first and foremost, IT needs to be a partner in this effort. The days where IT was this kind of ancillary group that you saw once every 3 or 4 months for whatever, or, when you need a new laptop, you filled out a request or whatever. Those days are gone. I read an article somewhere in IIoT that essentially said, and I'll mention this later, the line between process engineering, mechanical engineering, and IT is starting to blur. Because in the new world of IIoT, they need to work together. They need to be a very strong, well-linked team because they can't get the performance they need out of the system without that kind of integration. The last piece that I'll tell you is, look, at the end of the day, this is coming. This wave is coming. You can choose to be an early adopter and take all the benefits that come with that while your competition is still afraid of change, or you can lag and not be able to take advantage of that. So, in order to overcome the concern and the fear of newness and change, and I don't understand, small pilots are the way to go. So in a large corporation, designate a plant to be the pilot plant for this work. Or in a facility, pick a line. Hey, this line we're going to take to Bright. It's going to be a pilot. Once you start seeing the benefits of this, it'll be an avalanche and things will quickly follow because the benefits are overwhelming. And you can choose to get on the bandwagon or get left behind. So it's like any other change. It's going to take a little bit of time to overcome that resistance, but in my mind there is no choice. There is no option.
Yeah, it's actually profound what you've mentioned. A couple of things really were striking to me. The first one is this concept of, there's the promise of, reducing chaos, where you mentioned chaos and dimensionality and entropy. There are a lot of systems built around machine malfunctions, and this is from our world, of course. And those systems are preventive maintenance programs and some predictive maintenance and condition-based, and then redundancy, and all these different systems that are supposed to sort of buffer, I would say, a very basic and very real fear that you don't know when a machine is going to fail. And right. So, of course, when we combine new technologies and kind of come with the promise of, we will eliminate that fear. We will significantly reduce that uncertainty for you. And we'll be able to tell you exactly when that machine is going to fail, what's going to happen to it. There is still, I guess, a preference for a known fear or a known thing versus something that is unknown, right? Something that is new. And especially when it comes with buzzwords, or it comes with an understanding that needs to be gained about new technologies, new ways of doing things. So that was actually,
that's great perspective, because let's face it, you don't know when equipment is going to fail, but you have built total systems and organizations around that, right? In some locations, the maintenance organization prides themselves in being the knight in shining armor coming to the rescue of a line being down, right? And that's a tough nut to crack sometimes, because people take, and this gets into culture, which I'm sure we'll talk about later, but this gets into the whole kind of ethos of the maintenance organization in a facility, right? When do they shine? They shine when a line is down, and Eddie Smart gets out there, and boy, in half an hour, he's got that line up and running, and production's humming, and everybody pats him in the back because he came in and he or she were able to solve the problem. Where, in reality, in a well-run facility, the maintenance organization exists to prevent those failures, prevent that downtime. And it's a different mechanism, right? It's a different way of looking at what does success look like. But some people take their identity, right, their pride, in being the go-to person when the line is down, right? Now you're telling me, hey, I'm going to be able to tell you before it fails, you can change it out on a planned basis. There are culture. There's no question there are cultural implications of this revolution that's coming.
Yeah, absolutely. We see that all the time, and a lot of at least our customers have built tremendously well-functioning maintenance programs.
Right.
but there's definitely some inertia there, and it's very understandable. The other thing that you mentioned, just briefly, is this convergence or the blurring of the lines between IT, let's say OT, and manufacturing maintenance. And is it do you see that something that will become one role, or is it that in order to do your job well in this automated world, you will have to know technology and know the different roles differently than today?
That's a great question. I think there will be two different levels of knowledge and understanding, like there is today in a lot of these plant roles. So if you're in charge of a line, you're going to have some basic understanding of how these sensors work together, what they're telling you, how mechanically things work. When you're a manufacturing leader, you have to be a little bit of a jack of all trades, right? Because the line is going to throw different challenges at you. But I see a place in tomorrow's facilities for a data scientist, for somebody that can take all this data and create algorithms that explain why a process is doing certain things. So I see, to me, the change is today a manufacturing leader usually has a pretty good understanding of the mechanical aspects and the functioning aspects of a manufacturing process, the process, how it works. And the IT electronic side of it is, somebody else handles that. And I call the help desk when I have a problem. Tomorrow, they're going to have to understand how those systems work together and have faith in the data scientists, if you will, and their work to embrace the direction they're giving them. So I see, but in the past, those roles have been much more separate, and IT data really has been relegated to the process engineer. And listen, their bandwidth is about this big, whereas the data stream and the algorithms that are coming our way are this big. You're going to have need for those, data scientists is the word that I use, embedded in the plant to help you figure out how to optimize your processes. So that's the change that I see coming.
Okay, well, I really appreciate that. And I think when we're talking about the different promises that industrial IT holds, specifically in the industries that you've been part of, so the beverage industry, packaged goods of various types. How do you see those benefits, and that those promises actually playing out?
So I see this IIoT revolution impacting in four big buckets. I'm sure we could spend hours just talking about these, but in general, I tend to bucket them in four big categories or results areas. The first one, the most immediate, is automatic data collection. As mundane as that sounds, you would be surprised how much time is currently spent both by shop floor, hourly personnel, and management in just collecting data and putting it into some usable format. Is it an Excel spreadsheet or some homebrew version? In many industries, you still have the old, flipboard or tablet with a pencil or a pen, and they're recording information on there. First of all, very time consuming. Second of all, it is subjective. It is up to the person's interpretation of, for example, what caused the downtime. So if I'm running a line and all of a sudden I have a stoppage, as an operator or a mechanic, my focus is to get the line up and running. Once I get the line up and running, then I'll document what happened. And let's see, was it 15 minutes or was it 20? Was it this part that caused the problem? Or, you know what? I'm not really sure. The mechanic fixed something. So I put something down, because if not, the supervisor is going to come and say, hey, you were down for 20 minutes. Here comes something here, right? There is data integrity is a major issue, because most companies then take that information and analyze it, whether it's Pareto chart or some other methodology, to figure out where my biggest causes of downtime, and that's what I go and attack. And listen, the old adage, garbage in, garbage out. If you've been around for a while, you use the data, but you understand that it's not very accurate. So great opportunity. Automatic data collection will take away non-value-added work, so people can focus on more important things on the line, and will help with the validity and transparency of the data. So that's one. Traceability, I talked a little bit about that before, but the ability to track, raw material inputs through the process out to full goods and out into the marketplace and consumers is huge. Not only from a food safety standpoint, in case, God forbid, you need to recall product, but also from being able to understand the impact of raw material variability, whether that's liquids or beverage or containers or secondary packaging on the process. Right now, we capture the big outliers. Oh wow, I can't run that cardboard they sent me because look, it's bowed and all this. But the day-to-day variability goes unnoticed. And I would tell you, going back to the old, the days of total quality approach and Edward Deming, that normal variation will eat your lunch, but it's invisible to you. You don't see it. So that traceability is really important. Then we get into kind of higher level orders. The whole bucket of equipment effectiveness is huge. We talked about predictive maintenance, so I'm not going to beat that one to death, but another one that's very real and available today is quicker recovery from failures. So we know that most manufacturing and production processes are controlled by PLCs, right? They control the computers. There are even smart sensors that have programming in them. And typically what happens when one of those fail, there's first a mad scramble for, do we have a spare? But let's assume we do. So we bring the spare out into the line, but the spare is a dumb box, right? You have to give it instruction. You have to give it software. Now comes the mad rush for who's got the backup of the software. Now that gets really funny, unless you're the guy that's sitting there watching this happen and your line is done and you're not producing, because let's face it, in most places they do not have great discipline when it comes to backing up software. So if you're lucky, you'll find a thumb drive in somebody's toolbox that has a program that may be 9 months old, doesn't have the latest upgrades or tweaks, and you plug that in and you hope to God it works. And then you spend the next 3 hours putzing around with it if you're lucky. With IIoT, the dumb box is still the dumb box, but the software sits up in the cloud. So the moment you plug this PLC in, it is almost as easy as you hit a button and down off of the cloud comes the latest version of the software. It could have been backed up yesterday because it happens automatically. And you're up and running in no time, in a fraction of the time that would have taken you to get that line up and running, if you were lucky, if you had to spare and if you had the software. So I've seen issues like this take days to correct, and all around software availability. Within equipment effectiveness, other cool stuff like remote troubleshooting. Most manufacturing enterprises don't have embedded deep skills for their equipment. They rely on their OEMs to provide that. A lot of those OEMs are global now. They don't all reside in the US. In fact, in the beverage industry, many of them are located in Europe. And now you have to deal with potential language barriers and how do you explain what's going on. A number of the manufacturers that I've dealt with, that I've dealt with, are now trialing versions of the Google Glass product, right, that would allow technicians to troubleshoot almost real time with an operator as they're looking at the equipment, as they're looking at the parts from a continent away. That is tremendous in terms of its impact on downtime recovery. Then the last piece that I would tell you is the impact on the whole supply chain. So right now, the way supply chain planning works is they're assuming a certain production output. They look at your variability over time. That sets some sort of safety stock in your warehouse. They plan production to maintain that safety stock at a certain level, and then they ship from that, right? All that is static. It is not dynamic. It's based sometimes on 6, 12 weeks worth of data. imagine the how that gets sped up if you automatically know everything that's coming off the line, when it's coming off, and you're immediately alerted to any kind of process upset. Your recovery is almost immediate. Not only that, you can much better plan just-in-time deliveries of raw materials, and you're creating a pull process versus a push process for replenishment. That one has got tremendous implications and will really revolutionize supply chain planning and distribution. So I kind of put them in those four buckets in terms of how this technology is going to impact manufacturing overall.
Yeah, I kind of wrote down some notes here, and really you mentioned, you know, automation of data and being able to trace, increase effectiveness of equipment, and then optimize, I guess, the whole supply chain. And that definitely resonates. Where do you think, you know, maybe even more specifically, specific equipment, the processes, or, you know, the roles involved, where, you know, the highest need exists today, right? The biggest opportunity exists today.
Yeah, so the biggest short-term bang for the buck, from my standpoint, kind of three that I mentioned previously: the automatic data collection. I mean, that can happen today, and that's immediate return. PDM, another one that will provide immediate returns, and the failure recovery is another one, right? That can provide immediate returns. So those, I think, they're not experimental, they're real, they're now. You don't have to make big changes to your enterprise to be able to take advantage of those, and will be welcomed by the organization overall. And the first biggest impacts in the organization will be in production management and maintenance management. So the production and the maintenance organizations will be the ones first impacted and will see the biggest benefit short term out of implementation of this technology.
Great. I guess we're in the right space then.
Yeah, absolutely. Absolutely.
And then, you know, when we're thinking about the long-term effects, you know, again, you mentioned the short-term for maintenance and production, but the long-term effects, which roles, which parts of the organization will be impacted the most?
So long-term, I see, you know, as production gets on board, and then, you know, maintenance almost simultaneously, right? The quality control, quality assurance part of the organization will also be impacted, you know, through the ability to trace and QC can start looking at modeling the impact of raw materials, right? And help provide insights to come up with much better specs, for example, with the manufacturers. We may be paying a premium to have raw material come in, you know, within this level, this bandwidth of attributes, when in reality our process can tolerate this much without any negative impact on the business. So we're leaving money behind. On the flip side, we may allow suppliers to produce material in this bandwidth of attributes, when in reality, if they can do this, we can get 10% more out. So a new role for QA and QC. Also impacting them will be, they'll be liberated from having to be data collectors and more data analyzers. Secondly, the whole supply chain planning organization is going to change significantly. You know, there's a lot of industries have homebrew models trying to predict, you know, how when to replenish and all that. For one thing, if you have more immediate data, more information coming at you, you could potentially start dropping inventory levels because you know quicker when you have a problem, so you'll recover quicker. So you're going to need less just in case inventory. And your ability to replenish and provide greater customer service, greater levels of service to the customer, will also be improved by having this instantaneous insights into your production. And then let's not forget engineering. You know, you're going to start collecting some pretty interesting information about the failure modes of equipment and their actual life. So the last assignment I had at PepsiCo before I retired, we were just starting to scratch a surface of this with, frankly, not with a lot of manual systems. I had a great data person who I kind of stole away from an SAP kind of support role and focused on data mining. And some of the stuff that was coming out there were easy insights, but nobody had ever looked at stuff like this. So We have OEMs tell us, hey, this is the cost of ownership, TCO, total cost of ownership for this equipment. And we're like, okay, great. Interestingly enough, very, very simple. We just looked at how much money are we spending on equipment made by company X versus company Y, right? Because that was about as much transparency as we had. That's all we could really see, right? And amazingly, one company, the cost to maintain their equipment was half that of the other company. And we never knew this, right? How simple is that? But that started guiding some very tough conversations with that OEM. Getting them to understand that your equipment costs us twice as much to operate as this other company. How can you expect me to continue investing in your equipment? So there's a tremendous promise in engineering for this information. It's going to help some OEMs. It's going to hurt others. It's going to really shed light on items that we have no idea about right now.
So let's kind of talk about, we spoke about the benefits, short-term, long-term, and the kind of parts of the organization that this could actually benefit and impact. And you are yourself an early adopter of technology. And you and I have had conversations in the past. And so this is very clear. And of course, early adopters tend to be optimistic by nature.
Right.
But then, of course, a lot of times reap the benefits of new technologies, new behaviors, new trends. But then, when we're talking about those who adopt this technology early, what are the advantages to them? And those who don't, where will they lose out, if at all?
Yeah, that's a great question. Look, at the end of the day, the old adage, the early bird gets the worm. There's something to be said for that. But more specifically, it is a number of these areas that we've talked about offer almost immediate returns, right? We talked about data collection and PDM and all that. But the early adopters, while they're going to suffer a little discomfort, right? Because they're venturing into something newer. They're the ones that are going to see improved uptime, right, on their machines. Even just from a PDM standpoint, they'll have less failures. Less failures does not only mean less downtime, but it also means less repair maintenance costs. Because you and I both know that when something fails, not only does that unit fail, but it usually takes out 2 or 3 other things in the chain. So greater uptime, lower cost, greater levels of customer service. And I apologize, my laptop is linked to my phone, so it pops up every time my phone rings. Greater product availability for the consumer. Deeper understanding of their processes. That's going to be a huge insight. Once we really get into this, we're going to wonder how we operate it without it. We're going to be sitting there saying, oh my God, look at this. We long suspected, or, a good savvy operator intuitively knows some of these relationships, but they can't kind of put it together. Once we have the data, we're going to be wow, we didn't quite, we kind of intuited this, but we didn't know for sure. The data will tell us that. So at the end of the day, look, it all boils down to greater supply chain effectiveness all around at a lower cost, therefore greater profitability and and growth for the company. If you want to be left behind, let's a very recent example. Think about what happened to maybe not so recent for me because I'm an older guy, but think about what happened to the Swiss watchmaking business when digital watches started coming out, right? They almost disappeared. Yeah, you have your high end, the Rolexes and, Patek Philippe, stuff that, but that's really not for timekeeping, okay? That's a piece of jewelry, it's an heirloom. But you have a choice. You can this is coming. You can either be an early adopter and start taking advantage of it. And I don't mean that in a haphazard way, down the torpedoes, full steam ahead. Go after the stuff that is going to yield immediate returns, like the PDM part, like the automatic data tracking. Low risk, high return, go for it because you're going to reap the benefits. If you wait, somebody else is going to eat your lunch, and it's going to be your competitor. So,
I mean, that's great. And if we take that and kind of flip it and approach it from Augury's standpoint, or from the standpoint of a provider of that technology, what advice would you give us in terms of, how do we approach these early adopters, or how do we approach just customers in general and help them walk that path while going after the lowest risk, highest reward projects?
sort of, I think you have to attack the fears or the barriers that people perceive, right? So believe it or not, in some cases, you may have to start off with something as simple as explaining vibration and the whole failure curve and why vibration is the right tool to detect early onset of failure. Although I would think most folks in manufacturing by this time have understood that. The other bigger fear is, how invasive is this going to be? And how is it going to impact from a resource standpoint? And as I mentioned to you years ago, when I came across your company reading an article in Wired magazine, the thing I had experience with vibration monitoring when I worked at Scott Paper. So, probably 28 years ago. And I believed in the technology, but it required a very, very experienced vibration technicians to take the data. The data collection was not that big of an issue, but to interpret the information. When I've had my first experience with one of them, and they came to me and said, "Hey, Ed, you got to shut down this machine because you have a cracked inner race on the bearing of this roller." And I was like, "How the heck do you know that?" I was like blown away, right? But this guy had been a submarine guy. He had, spent 15 years looking at this stuff. And it really amazed me. The barrier had always been, who are these people that can do this, right? Who are they? How do you source them? Can I keep them busy? And the answer most of the time is no. So when you approach a traditional manufacturing person and ask them about vibration analysis, they'll probably say, "Yeah, we got it, but we can't afford to have a vibration person here all the time." Or, "Yeah, we hire somebody, they come in once a year and they do a round and they find a couple of things." What really excited me about Augury is you guys provide all the benefit with none of the headaches, okay? You outsource predictive maintenance. The data gets captured automatically, in the case of your Halo systems. You have the oscilloscope if you want to troubleshoot particular pieces of equipment. But for the plant, nothing changes. They just see these boxes connected to their equipment. And they start getting emails, right, that say, "Hey, we've detected your equipment is good," or "We detected abnormal levels of vibration. And by the way, here's what we think the cause is, and here is the fix." And also, it's not just generated by an AI, kind of the thing behind the curtain. You have that, but you have real people that look at this data and based on their experience say, "This is what I think the issue is." That is extremely powerful. And from a manufacturing standpoint, you can take away the concern of, "Oh, I need to hire a vibration tech. I need to do." No, you need to let us come in and put the system in, and it'll be invisible to you until you have a problem. That's the real promise that Augury can bring to the table.
Well, I of course appreciate that, and I think we're kind of nearing the time that we have a few questions from the audience, and so I'd like to give the audience a chance to kind of ask them. We have a couple here. One question, which I think is very interesting, is around cultural change. So, how do you see these technologies kind of changing the culture within manufacturing?
So I've kind of hinted a little bit about that in the previous discussion, but it is going to be a major change to manufacturing culture. First of all, the decisions, right, made regarding manufacturing production lines will be much more data-based. I mean, that's huge. You still have some people that make decisions based on gut feel, and there's something to be said for gut feel. I really believe that gut feel really refers to data that we have somewhere in here that we can't quite access. It's like available, but consciously you can't get to it, but subconsciously you make some connections and you go, that doesn't feel right. Got it, right? But that doesn't take the place of database decisions. Now with all this information, you will have data drive the decision making, which I think is huge. It takes a lot of the personal bias out, or the, oh, we didn't do it like that last time. So that's very powerful. The Augury motto, I think, says it very well. Machines talk, we listen. I've always told people that the equipment tells us things. Its success is based on our ability to interpret what it tells you. Can you understand its language and do something about it? So I thought your motto was pretty catchy. But getting back to the whole question of culture change, we talked before about the coming together of mechanical engineering, process engineering, and IT/data engineering, right? Everybody in the organization is going to have some level of capability in those realms, but you're going to need dedicated resources to help you deal with this data, interpret it, and tell you what to do about it, right? So that's a change. Usually, IT guys, the jokingly used to refer to them as the Trons, right? They kind of sit over there and, they come out once in a while, fix a few things. We only call them if we need them. No, they're going to have to be integral part of your manufacturing team. And really deeper understanding of these manufacturing processes and manufacturing flows. I think that's going to be terrific. It'll be a data-based world as we look down the road.
Let's see what else we have here. Okay, so I think we have time for a couple more questions. One question here is around the metrics that's kind of tangible. What is kind of one of the key metrics that could be improved with IoT? Is it some kind of KPI that you said that's different for what you're tracking right now? Is it OEE? Is it TE? What do you think the key metric for implementation of these technologies would be, or one of the key metrics?
Certainly. So certainly some measure of uptime, right? Some companies use the kind of industry accepted OEE measures. Others shade a little bit and call it RE. Some companies really focus on TE, which is running efficient. RE, which is running efficiency. Some just call it line efficiency. So lots of different interpretations, but they're all based on some measure of uptime reliability. So that's first and foremost, but it's not all encompassing. So we talked about things like waste, right? Good running equipment generates lower levels of waste. So tracking your waste performance, very important, right? As equipment starts to fail, and this is something that, over the years I tried to ingrain in folks in my organizations. When a piece of equipment fails, and it catastrophically fails, right? It breaks, it stops working. Many times, that is the culmination of a failure process, okay? That piece of equipment could have started failing 4 weeks ago, and maybe not detectable at first, but over time, that could have been the cause why you had intermittent quality issues. In the bottling world, many times we will see intermittent filling issues coming from a valve before it completely fails. But in the meantime, you've got low fills coming out, you have off-quality product coming out until it finally completely quits on you. And now oh, wow, I got to replace it. So waste is important. Quality would be another. And I mean, there's other stuff down the road. I mean, potentially total hourly productivity would be impacted. Supply chain costs, sourcing costs, et cetera. But the other ones you should be able to get pretty immediately. So you should be able to see that.
We have to wrap this up. We're just nearing the end of the hour here. And this has been really, really fascinating. And really appreciate you joining us in this discussion. And also, I want to thank all of our participants that have submitted questions and participated and took the time to listen to our conversation. We'll have many more of these in the future. And so I hope to see everyone back here with us in the future. Ed, thank you so much.
Hey, Artem, thanks for the time. It was a pleasure, and I hope the folks who were listening got at least one little tidbit out of it. Oh, I certainly enjoy the conversation. Thanks a lot for your time.
Okay, thank you.
Bye-bye.